and welcome back to another KTaNE module tutorial. You know why you're here. Welcome to module name. So you may notice that I already had the bomb running. This is because I have painstakingly went through the effort to make sure I show all of the cases, including every single individual blank slate case, and that's what you see these numbers here for. Those are the cases we're going to cover, and then we'll just do a regular module name last to show you how the module actually works. No, we'll do it first. We'll do the regular module name first. We'll leave these for later. Well, no, I'll just show you how it works first, and then we'll go through the cases. That's what we're going to do. So, the module initially appears blank. You can click the module as many times until it shows this like source code thing here. That's why I have the page source open. So let's click it. 4, 5, 6, 7. So we have pressed it 7 times. You need to write that down. That's what all these numbers are. And it will give you a piece of source code. So you have to go into the source code of the module by, in the manual, right-clicking, pressing View Page Source. And then we need to find this string. So the string, like, the first piece in the string is going to be the outermost line, which is always here. And then anything to the right of it is always going to be nested points inside that. So we have OL1, which is this one. There's only one OL, and LI1, which means we are looking at Hertz. Because you go to the link at the point you land on. So now that we know how the mod works, let's start going through the cases. So these are actually ordered weirdly. These 3 are these 3, and these 5 are these 5. So we're going to start with Hertz. So let's start with Hertz here. So let's go to the Hertz manual. So yeah, once you click on the module after the source code appears, there will be a 10-digit keypad and a display. The display submits your number. The keypad types in a number. So for Hertz, so how do we do the Hertz case? So modulo the amount of clicks by 7. So 5 mod 7 is still 5. And look it up in the movement table on indicators. So we go to this table on indicators, and we go to the amount that, the amount of times we pressed it, mod 7. And it's 5. So 5 for indicators is left twice. And then we take our display color and we query that in the LED rows. So in this case, green in both would be up. So starting from the middle in both tables, just like the actual Hertz module, we're going to perform these movements and get 2 numbers. So we need to go up, up, left, left, up, left, left, and same down here. Up, left, left, and we get our 2 numbers. We have 857, and we have 0. Now, if you were to get 0 on this top table, which normally isn't possible in the actual Hertz manual, you would make it 200, because the module name says so. Okay, so from the second table, the turning the word into a number table, we take our digit here, which is 0, and we modify it based on only this phrase. Only this one. Everything else is null and void. So after we find our number, add 1, and multiply it by 1 more than the amount of port plates. There are 2 port plates, so 1 more than that is 3. Multiply it by 3. And that's it. That's all we modify the number by. Once we've modified the number, we divide the larger number that we got in the first table by our smaller number. We will modulo 64 and remove all decimals, so 285 mod 64 is 29. And we convert it into binary and submit. So the binary of 29 is 11101, and that's the Hertz case. For any given module name module, it will have 2 stages. When you hear that ding, that means you got the stage right. and you can move on to the next stage. If you ever strike, it will go to before the first stage. So you will have to do the entire module over again. These are all going to be the first stage because I just picked these by re-rolling the mod until it gave me the case I wanted. So let's move on to the next one. What is this? This is Simon's statement. Now this one, to most people, is the most confusing statement. The most confusing case in the module. So let's head to the Simon statement manual. Let's head to the Simon statement portion of this module. So, determine the stage number as set in the manual. That is kind of misleading, but this step says determine stage number, so we'll do that. And there are a few little quirks. So first, the stage variable, this, is equal to the amount of times the displayed color changed plus 1. That will only be relevant after this first calc. And I'll explain why in a minute. Also, the serial rule is interpreted by this manual. A letter from the serial is an lit indicator. Add to and don't look for it again. So you look for the letters if they're in lit indicators, and you only ever add to if it's there once. So, and also the duplicate port type rule can only apply once. So this rule for every duplicate port type, this is for only one. You can only do this once. You can only subtract 4 once. So starting with 0, for every serial number character present in a lit indicator, remember this can only apply once per letter. So it doesn't apply at all, so we don't have to add 2. For every duplicate port type, we don't have any of those, since all of these are unique, and there's only one instance of them. Add the number of batteries multiplied by ports. So the number of batteries is 3, multiplied by the number of ports is 5, that's 15. So we're adding that to 0. Multiply by the stage number. Okay, so the stage number for now is 1, because the display is not changed. So we are on stage 1. Every time you type in 2 numbers, the display color will change. That's how the statement mod on this module name works. And every time it does that, you will have to recalc this number with that stage variable changed. So the first stage will be 15, the second will be 30, the third will be 45, the fourth 60, and so on, so on. So starting with 15. So we have our number 15. So we've done all this, and there's a couple rules for like what to do if the number, if it's negative, you do the adding rule, it says, so add 25. If it is a single digit, swap the digits. So say we ended up getting 4, it would be 40, because you just add a 0 after it. And if it's 0, it's always 10. And if it's greater than 49, so if it's 50 or above, you subtract 25 until it's within the range. So using the color of display and the next color in this list, so the list is blue, red, yellow, green. So we take the display color, green, and the next color in the list, wrapping around, which would be blue. These are going to be our 2 inputs. These are the true inputs for our operation we're going to do. To actually get our statement, first we need to find the operator, which is the amount of clicks mod 8 plus 1. 15 mod 8 is 7, plus 1 is 8, so our operator is imp by. I should put that down here, because it's just going down this table. So 1, 2, 3, 4, 5, 6, 7, 8, which is imp by. Which basically means if it is 0 imp by 1, it is false, otherwise it is true. Make the colors in the statement the number of battery holders, 2, plus 1 is 3 for left. So the left input is going to be 3, which you convert that using these parentheses. 3 is yellow, so we have yellow implied by port plates mod 4 plus 1, which is also 3, so it's yellow implied by yellow. Since it's the same color, and since we know the only way it can be false is if it's 0 imp by 1, this will always be true, so we don't have to bother checking this anymore. Usually you will have to bother checking it, and you'll have to recalc the true inputs, and yeah, just the true inputs. The statement will always be the same. So now what we do is we look up the number we got in the table based on step 2. So if the statement on the display is true, yellow imp by yellow is true, so we're using table A for this. So 15 lands on yellow. So what does this mean? After we input the value we calculated, the display will change. If the display is then the color we calced, then we must press the display immediately and the stage is over. Otherwise, we have to repeat the process and recalc the stage number again, but with multiplying by 2 this time instead of 1. So let's go for it. 15. Blue. Blue is not yellow, so we're doing it again. So it's the same calcs, so we still have 15. Times 2 is 30, because the display has changed once, so we multiply by 2, which would be 30. It's not greater than 50, so we're just staying with 30. So our true inputs this time would be blue and red, but again, it doesn't matter. This is always going to be true, and we just do this again. So since we know it's true, we're using table A, so 30 in here, 3, 0. It is changed to green, and green was the color we landed on, so we press the display, and the stage is over. There can only ever be a maximum of 4 repeats of that. The 4th time you input the 2-digit number, press immediately, no matter if the color matched or not, because the display cannot go over 8 digits and it will strike you if you try to do so. So that's Simon's statement. That's the most complicated one out of the way. Let's move on to something a lot simpler, not green arrows. So here we are. Take the amount of clicks. In this case, our not green arrows clicks were 11. Mod 4 is 3. Plus 2 is 5. That's how many statements we're going to be checking. Let me go to the not green arrows manual. That's how many stages for each arrow we're going to be checking from top to bottom. So let's just go ahead and do that. This is the same procedure as in the actual not green arrows, if you already know how to do that. The only difference is the letters don't come from the display. They come from the first letter of the serial number, which is delta in this case, followed by the first 2 letters of the color, which is BL. This color, by the way, is always one of red, green, yellow, or blue. There's no other colors. That's why there's only 4 blank slate cases, because each color corresponds to a different case of blank slate. So, we have this. Okay, so let's go through it. The first letter, so let's go through these conditions. So, we need 5 from each, so that would be 1, 2, 3, 4, 5. 5 dash points for each of them. So let's go through them. So the first roll for each. The first letter is not a vowel. The second letter is also not a vowel. None of the letters are vowels is true. The third letter is a vowel is false. Sum their alphanumeric positions is a prime number. Delta is 4th in the alphabet, Bravo is 2, and Lima is 12, which is 18. So it's not prime. 18 is divisible by its digital root, because its digital root is 9. It's not an odd number, and it's not a multiple of 7. There are no duplicate letters, so none of these other rules will apply, because they all talk about letters matching. The second letter is present in the serial. No. None are present. No. Third is. No. First is. And then U is present is false, D is present is true, L is present is true, and R is present is false. So we have our 4 amounts. We have 1, 2, 2, and 1. So what we do is we take one of them with the highest amount of statements, in this case 2, and that's our first digit. And we input the other 3 from lowest to highest. So we have 2, so let's take this 2 out of here. So lowest to highest after that would be 1, 1, 2. So 2, 1, 1, 2. And that solves that case. Not a very complicated case. That's one of the better ones. It's one you usually want to get. So let's do the last non-blank slate one before we actually move to the blank slates, and that would be one that really stands out here for being a lot harder than the rest as a module. As a module name case, it's not that hard, but as an actual module itself, Octa is by far the hardest. So I actually rolled a pretty bad octacase here because it's only 3 dimensions, so I can't really explain it that well. But basically, you start at 3 dimensions, and every 3 clicks that you have made, so say we have 6 clicks, that would be 3 and then 3 again, increases it by 2. So the first 3 would be 2 additions and then another 2 additions for 7 total. So in this case, we only have 3 because we only have 2 clicks this time. So we take this string, so for the amount of dimensions that there are, you take all of you take all of the dimensions in order and make them one big subrotation, which is always just going to be in the form of dimension 1 plus dimension 2 plus 3 plus 4, 5, 6, 7, 8, 9, and so on. It can actually only ever go up to 9 dimensions, because the maximum amount of clicks you can get on this mod is 11. So in this case, we have 3 dimensions, and we need to choose which dimensions become negative based on the color. So in this case, the blue display will change the first and third rotation to be negative. So in this case, X would be negative, and Z would be negative. So now that we have our rotation, we need to go to this table. This table will be bigger if you have more dimensions. Let me just show you. Let's say like 9 dimensions. The table's bigger because it's all the rotations and their possible next axis. So we need to take these in pairs. So we take the first and second as a pair, then the second and the third as a pair, and then third and fourth and fifth, and so on. And we're also taking the last and then the first as a pair. So in this case, we have negative X, Y as our first pair. We have Y, negative Z. And we have negative Z, negative X. So we need to look these up in the table using the first axis as a row and the second as a column. So X, Y is our first, would give us 2. If exactly one of the dimensions is negative, invert the number. So in this case, we get a negative 2. YZ, we have a 6. Since only Z is negative, that's a negative 6. And then ZX. If they're both negative, just treat them both as positive because it's the same thing. So ZX would be positive 9. So we add all of these numbers that we got from the pairs. We add them all up. And this is our final number. So we have 1. If, after doing this, you will, if you get like a number bigger than you're supposed to, or a negative number, you will have to modulo by whatever it says. For 3 dimensions, it's going to be 8. For 4, it'll be 16. 5 is 32. 6 is 64, so on, so on. In this case, we got 1, which is in the range of 0 to 8. So now we convert this into X-digit binary, where X is the number of dimensions. So in this case, we have 1, so we need to convert it, and we have 1, and we have 3 dimensions right now. Remember, X, Y, Z. So we need to convert it into 3-digit binary. 1's binary is just 1, so we prepend zeros until we get to 3 digits. 0, 0, 1 is our binary. Make the first digit a 1 just for easy converting into gray code. And now we actually convert into gray code. So to convert into gray code, we take the first digit of our gray code. Our gray code will be the length of the binary number we started with. We always start with a 1, just because that's how it works. And now we take our previous number and the number next in the binary position, and we XOR them. As in, if they are both different, it will be a 1. If they are both the same, it'll be a 0. So in this case, 1 and 0 are different, so our next digit's a 1. 1 and our next digit, which is 1, 1 and 1 would be 0. So 110 is our final gray code and is what we input into the module. Bam. That's the Octadecayotton. So now that we've covered all of the cases that aren't blank slate, let's cover the 4 blank slate cases, which is what took this so long to reroll for. So let's go to blank slate. And the reason I say 4 blank slate cases is because that's how it works. The color of the display determines what section you're looking for in the blank slate manual. So let's just go in order. So starting, so since I know the colors, I'm just going to put them in order. So blue, red, yellow, green. So starting with blue up here, we have this first section. Nothing initially happens. So let's go to the nothing initially happens section, section 8. Which is, we're not really looking at that section because it doesn't really say anything. So we need to split the number of clicks into 4. So we're taking the number of clicks, which is 4, and we're adding it to 4 different constants. In this case, the first one is clicks plus port plates. 4 clicks plus port plates would be 6. 4 plus batteries would be 7. 4 plus solved modules. We actually don't have any on this box, so it's still a 4. It's calculated when you do the final press to take it into the submission mode. And clicks plus battery holders. 4 and 2 is 6. These numbers are not allowed to be used in the answer, and the answer must contain 5 unique digits from the valid numbers in order. So we can use any of 1, 2, 3, 5, 8, 9. We don't use 0 because the display doesn't like to register zeros very well. So 1, 2, 3, 8, 9. Bam. That's the blue blank slate done. Now for the red one. The section chosen is high-pitched sound plays. So that's what we're going to go to. High-pitched sound plays. So this section, section 6. Using only the columns in rows 1 to 5 of the table, with column being the amount of clicks, 3. Mod 5 plus 1, so 4, so we're using column 4. And the row being the second digit of the serial, 1 plus 1 is 2. So row 2. Orange. Add the color value with 7 times the amount of clicks. So 7 times 3 is 21, and the color value for orange is what we landed on, is 9. So it'd be 30. That's it. Lol. Now we get to the worst blank slate case, which is yellow, which is the hinge falls off section. Now, our initial column is the amount of clicks mod 8 plus 1. So, in this case, 4 plus 1 is 5 is our initial column. And the rows, we have ports mod 8 plus 1, which is 6. We have batteries mod 8 plus 1, which is 4. We have lit indicators mod 8 plus 1, which is 2. So we take the middle row number obtained, mod 8 plus 1. Yeah, the middle row number, mod 8 plus 1. In this case, the middle row number would be 2, which would be 3. And then we input the numbers at these intersections. So starting with ports, then batteries, then indicators. So ports was 6, that's a 7. Batteries is 5, and indicators is 8. And that's that case done. And then finally, we have the blank slate green case. And this one is for tap code plays. So we have tap code plays. Look at the table and take the row is the amount of clicks, 9, mod 7's 2, plus 1 is 3. So third row, take the first word from left to right that is one of their letters appear in the serial number. So we're taking the first word in this row that has either a D or a Q in it, which would be this one, LED. And we convert this into tap code and submit it. Don't turn my Wi-Fi off. That would be a very bad idea. So we turn this into tap code. We need to turn LED into tap code, which we can just use the tap code manual. L is 3-1. E is 1-5. You always use row then column. And D is 1-4. And we input that into the module. 3-1-1-5-1-4. And that's every single case in module name covered. Now, for a final, bit, I'm just going to solve one of the modules just by doing the second stage to show you that's actually how many stages there are. So let's just do this last one that we ended off on, a blank slate. 3, 4, 5, 6, 7, 8. So we got 8. Now we search for what this is. This is TR2. So 1, 2, and TH1. So the first TH, which is Hertz, which is really nice. Because Hertz is probably the easiest case by far. So 8 mod 7's 1. So we're looking for 1 and green. So we go up, up, upright once, upright twice. You always loop. So we have 345. We go up, up, upright, upright, 6. So 6 plus 1 is 7. Multiply it by 1 more than the amount of 4 plates, 21. So we go 345 over 21 is 16, which we would then just submit as binary. 10000. And the module is solved. That's it. That's module name. I worked really hard on this one, so yeah. Thank you for watching, and please, be safe, I guess. I don't know. Bye!